Okay, let's start chapter 14. In chapter 13, we talk about production functions and total cost functions and the relationship between different types of cost curves. So, chapter 13 is the foundational chapter. It gives you the basis to understand how firms make decisions in different types of market. Now, today, we're gonna talk about the first type of market, which is competitive market. So it's the simplest type of market we could learn. First, let's define what is a competitive market. By by definition, we assume in this competitive market there are many buyers and many sellers. Why do we require this market to have a lot of buyers and sellers? Well, because we want to make sure that each buyer and each each seller would only have very little impact on the market. In this case, we basically call these buyers and sellers in the competitive market as price takers. Again, the reason is because you have so many buyers and sellers. So each one of them only has very little impact on the market price. And in terms of terminology, com- we sometimes call competitive market as perfect perfectly com- competitive market or market with perfect competition. So for this firm in a competitive market, we call this firm as competitive firm. So you can see that the competitive market has three features. The first feature is we have many buyers and many sellers. Then the second feature is products in the market are roughly the same. Third, we also assume firms can freely, costlessly enter or exit the market. And you can see that for and you can see that under the first and the second assumptions, we will have this result. That is, all buyers and sellers are just price takers, right? Because you can see that first, again, we have many of them, so they cannot generate a large impact in the market. And then all products are the same. It means that there are no product differentiation in the market. So sellers won't have any power from product differentiation. So again, under the second assumption, all sellers and buyers, they will be just price takers. And then the third assumption is used for long-term equilibrium. In the second half of this chapter, you will see why we need assumption 3. But now you can see that assumption 1 and 2 will basically give you the idea that buyers and sellers are price takers in the competitive market. So what is a example of a competitive market? So a example for this competitive market is the market for milk. You can see that in the market for milk, we have so many buyers, and each single buyer will only buy a small amount relative to the size of the market. So this basically implies that no single buyer can have this influence over the market price of milk, right? Then we could talk about this from seller's perspective. You can see that milk products are roughly the same. Of course, you could have 1% 2%, 3.25%, but in the end, all 1% milk products are roughly the same. So you can see that because products are the same, then these sellers, they cannot charge more, because if this seller charges more for this 1% milk, then buyers will just go somewhere else, right? So you can see that in the end, in this market for milk, roughly speaking, buyers and sellers, they're just price takers. They take market price as given, and the milk product is a example of competitive market. Now let's talk about profit maximization in the competitive market. So why do we talk about this? There are at least two purposes. First, we want to understand how firm determines its quantity in this competitive market. Second, we want to understand how do we get this so-called supply curve, right? So if you recall the first half of this this intro to micro class, what you would see is we talked a lot about curves, right? We talk about demand curve and we talk about supply curve. And one important question is, how do you get this guy, right? How do you get this so-called supply curve? Well, now through understanding firms' profit maximization in this competitive market, you will be able to see that supply curve is essentially the marginal cost curve. So let's proceed and see how this works. Obviously, to examine a firm's profit, we have to define a firm's profit. And we have done this, right? In the last chapter, we know that profit equals revenue minus total cost. Of course, we have also learned calculating total cost is not that simple, right? Because you have to understand what is the implicit cost, what is the explicit cost, and you also have to understand fixed cost and variable cost. Of course, total cost equals fixed cost plus variable cost. So by definition, total revenue is really price times quantity, right? Very easy. And then let's consider this simple example. So let's consider a specific firm. It's a milk firm. It's called Smith Family Dairy Farm. So let's first look at this table, which gives us quantity, price, total revenue, average revenue, and marginal revenue. Clearly, we have learned about these three guys, right? Quantity, price, total revenue. And we understand what is the quantity, what is the price, and how to calculate total revenue. So now let's look at this new guy here, average revenue. Well, by definition, right? Average revenue is really total revenue divided by quantity. So you can see that if you want to get this number 6, what you want to use is these two numbers, right? So you can see that total revenue is 12, quantity is 2, and then average revenue would be 6. Of course, you could also use these two numbers. So you can see that at quantity of 5, average revenue is 30 divided by 5, which gives you 6. Now, if you look at this column, this average revenue column, you can see one interesting result. That is, the average revenue equals price. They're both 6, right? Is this a special result? Well, it is not. So for any type of firm, average revenue always equals the market price. How do you see this? Well, we know that total revenue equals price times quantity, right? So you can see that total revenue divided by Q, and you can see that these Q's would just cancel out. And now you get a P. So this is the result, that is average revenue equals price. Now let's look at marginal revenue. First, let's define marginal revenue. Well, we have defined several marginal quantities, right? Marginal product, marginal cost. So if you understand marginal product and the marginal cost, then it should also be easy for you to understand marginal revenue. So in terms of economics, marginal revenue means the increase in total revenue from one additional output. In terms of mathematics, right, it basically means you could use the change in total revenue divided by the change in quantity. Again, this delta means change, right? So that's how you define marginal revenue. And for a competitive firm, marginal revenue equals the price. How do you see this? Well, let's say we have, let's say the market price is P. Let's say the firm's quantity increases from Q1 to Q2. Now let's calculate the firm's marginal revenue. Well, by definition, right, you have to use the change in the total revenue divided by the change in quantity. And what is the change in total revenue? It's just the PQ2 minus PQ1. And the change in quantity is just the Q2 minus Q1. And then you can see that this is equivalent to P times Q2 minus Q1 divided by Q2 minus Q1, right? Now it's pretty obvious these Q1 minus Q2, these Q2 minus Q1s will just cancel out. So in the end, you will get this very simple number, price. Okay. Oh, I should also emphasize that this marginal revenue equals market price only holds for competitive firms. That is, it only holds for firms in the competitive market. Now this seems trivial, but in the future you will learn other types of firms, other types of markets. And you should always remember that MR equals P only holds for competitive firms because this does not hold for other types of firms in other types of markets. Okay, now let's go back to this this example here and see how could we calculate marginal revenue. So first, let's use the change in total revenue divided by the change in quantity. So let me remove these old markings. So let's say we look at these two numbers, right? So in this case, you can see that as you increase the quantity from 3 to 4, total revenue increases from 18 to 24. So this is a difference of 6. This is a difference of 1. So you would use 6 divided by 1. This gives you 6. So this is the marginal revenue. And you can see that marginal revenue is always 6. The reason is because the price is always 6. Right? And we know that marginal revenue equals price for a competitive firm. So you should get 6 for marginal revenue at all quantities. Okay, now let's see this very simple question. When I competitive firm doubles its output, what happens to the price of its output? So remember that this is a competitive market, and a firm in a competitive market is always a price taker, which means the firm will take the price as a given. So even the firm doubles its quantity, the price should stay the same. So you should say price stays the same. Now what about total revenue? Well, total revenue equals price times quantity. So if price stays the same but quantity doubles, then you would know that total revenue should also double. Right? So in this case, you can see that total revenue doubles. What about average avenue? Avenue. No, it's not. Sorry, it's not avenue. It's revenue. I don't know why do I have avenue here. Let me go back to this. So its average revenue should stay the same, right? Because we know that in this competitive market, average revenue equals price. So in this case, you can see that if price stays the same, then average revenue should also stay the same. What about the marginal revenue? Well, we know that for a competitive firm, marginal revenue equals price. So you can see that both quantities, right? Average revenue and marginal revenue, they should also stay the same if price stays the same. So they would stay the same. Okay, as I have mentioned, we want to understand how could we get a firm's supply curve. And I also mentioned in this competitive market, marginal cost curve will give us a firm's supply curve. So now let's examine how could we get this result. Okay, now let's use again this milk producer example. So now we have some additional quantities. We have marginal cost and the change in profit. So let's think about the firm's profit maximization problem. Essentially, we want to understand when this firm is maximizing its profit. So you can see that now obviously we have to understand what is this firm's total cost. So if we have the firm's total revenue and total cost, it's very easy for us to calculate the firm's profit. And then we could also calculate the firm's marginal revenue, and we have done so. We know that marginal revenue is always $6. And we also have and we could also find out marginal cost, right? We have defined marginal cost in the previous chapter, and we know that marginal cost is the change in total cost divided by the change in quantity. So here we get 4, right? And what about this change in profit? Well, later I will talk about change in profit. Now let's first answer this important question, right? At what quantity this firm is maximizing its profit? Well, this is also very easy, right? So you can see that at different quantities, the firm is having different levels of profit, right? For example, if the quantity is 1, the firm earns a profit of $1. And clearly you can see that firm's profit is maximized at $7. And what quantities can we have $7 of profit? cost. It's 4 or 5, right? But we could observe some more interesting and important pattern here. What you can see here is if you increase quantity from 0 to 4, right, let me draw this. So if you increase the production from 0 to 4, you can see that the profit always increases, right? Increases to 7. However, if you go from 5 to 8, the profit will actually decrease, right? So what I can see here is basically it says that as you increase your profit, as you increase your quantity, you will get higher profit. But if you go past this, optimal quantity of 4 or 5, then if you continue to increase your quantity, your profit will actually decrease. Okay? It's a quite easy to observe result. Now, if you look at the last column, you will get some result like this. So for these columns, marginal revenue minus marginal cost is positive. So at these quantities, M are larger than MC, right? And then you can see that for these quantities, we have either 0 or negative number. So here we have marginal revenue smaller or equal than marginal cost. Now what's this result we can get here? It basically says that if marginal revenue is larger than marginal cost, and as you increase the quantity, your profit will increase. If marginal revenue is smaller than marginal cost, as you increase your quantity, then profit will decrease, right? So that's the result we truly want here. And this is a very important result, and it's not a special result because this result can be applied to any competitive firm, right? So again, let me repeat this for a second time. So for any competitive firm in the competitive market, if marginal revenue larger than marginal cost, then increasing output will increase the firm's profit. If marginal revenue is smaller than marginal cost, then decreasing output will decrease the firm's profit. Now, what is the right quantity to maximize this firm's profit? Well, it's the quantity at which marginal revenue equals marginal cost. So essentially, this tells you a firm's profit maximization condition is MR equals MC, right? Marginal revenue equals marginal cost. Now, why do we have this result? Well, if you recall the cost curves we have learned from the last chapter, now you will see that if marginal revenue is larger than marginal cost, right? For example, let's say if you're at the Q1. Okay, let me change to a different color. So let's say if the firm's quantity is Q1. Now, what is the marginal revenue here? Well, this is the marginal revenue. The reason is because it's a competitive firm. So marginal revenue equals price. What is marginal cost? Well, you can see that we have a marginal cost curve here, right? So you can see that the marginal cost curve is really the intersection of this Q1 and this marginal cost curve. So now we will have MC1, that is marginal cost at Q1. Now, obviously here marginal revenue larger than marginal cost. And you can see that the firm will want to increase quantity at Q1. The reason is because marginal revenue is larger than marginal cost. This basically means the firm will get a larger revenue from additional outputs compared with its cost, right? So on the margin, the firm will want to increase its output. And then if you look at Q2 here, then you can see that this is marginal cost and this is marginal revenue. So here you can see that marginal cost is larger than marginal revenue. It means that the firm is essentially producing too much. It is losing money, right? Because the cost is larger than revenue on the margin. In this case, you can see that the firm will want to reduce its output. So in the end, you can see that the right amount is Q max, that is the quantity, which maximizes the firm's profit. Now, how do you get Q max? Well, it is really the intersection of marginal cost curve and this price line, right? So we know that if marginal revenue equals marginal cost, then this firm is maximizing its profit. But we also know marginal revenue equals price. So this basically tells you a competitive firm is maximizing its profit if price equals marginal cost, right? Now, you will learn this. Now we have learned this basic or a fundamental result on how a competitive firm maximizes its profit. So its price. Oh, sorry. Oops. Boy, this app is really terrible. So we have learned about this result, right? So for a competitive firm, when it is maximizing its profit, MR equals MC. And we also know that MR equals average revenue, which also equals price. So you can see that all these equalities will hold for a competitive firm. Okay. Now let's see this simple, very simple question here. So let's say you have graduated and you landed a job in Bombardier. So you're responsible for the firm on Sunday. Let's say your firm has a cost like this. So if the firm produces 500 jets, then the average total cost would be 200K. And if the firm produces 501 jets, then the average total cost is 201K. Now let's say the firm is now producing 5 jets, and all 5 jets have been ordered by WestJet. And now Elon Musk wants to buy 1 airplane, right? Well, the firm is already producing 500 jets, and all jets have been bought by WestJet. So now you have to boost the production level to 501. And Elon Musk says he's happy to pay you 450K to produce this extra unit. So the question is, should you accept his offer? Now, you have to think about this problem on the margin. That is, you have to think about marginal revenue versus marginal cost. So what is the marginal revenue in this case? The marginal revenue is the additional revenue your firm can get from boosting output to 501, right? So what is the marginal revenue here? So to solve A, we have to find out marginal revenue. In this case, you're thinking about boost the output from 500 jets to 501. And then you can see that, let's see how your total revenue will change. So if you have 500 jets, then your total revenue is 200 times 500. Remember, this 200K is really the average total cost. So the total revenue should be, I think it's a number like this. So it's 100,000 K. And if the output of the airplane is 501, then the total cost would be 201K times 500. Oh, sorry, it's not 500, it's 501. Okay, so let me use my calculator to find out the number here. So we have a number of 10701K. So now you can see that by the definition of marginal revenue, right? So if you get one additional airplane, your revenue will increase by how much? Well, 701K, right? Oh boy, you know what? I made a big mistake here. This is actually average total cost. So basically we're actually discussing total cost here. So the total cost here is, if you have 500 jets, then your total cost would be 100,000 K. And if you have 501 jets, then your total cost would be 10701 K. So your marginal cost would be 701 K, right? So basically, if you want to produce one additional jet, then you have to pay 701 K higher cost. Now let's talk about marginal revenue. By definition, right? Marginal revenue is the additional revenue you can get from one additional output. Here, if you produce one additional airplane, then you can sell this additional airplane for 450K. So here, marginal revenue is 450K. So you can see that if you compare marginal revenue versus marginal cost, what you can see here is marginal revenue is actually smaller than marginal cost, right? So this basically tells you that you should not accept this offer, because if you accept this offer, your firm will lose money. And question B asks, what is the net change in the firm's profit if you accept his offer? Well, this is easy, right? So the net change would be marginal revenue minus marginal cost, which is 450 minus 701. I believe it's 251. It's minus 251. Yeah. So if you accept his offer, the firm's profit will drop by 251K. Okay. Now, let's discuss why marginal cost curve is the firm's supply curve. Right? So, remember that we learned about the firm's maximization condition. That is, price equals MR equals MC equals average revenue. So let's just focus on this. Price equals marginal cost, right? So what does this mean here? It basically means that if price is P1, then the quantity will be determined by the intersection of price and the marginal cost. Right? So the quantity will be given by Q1. And now if price is P2, the quantity will be determined by the intersection of P2 and the marginal cost. So quantity would be Q2. Now what does this really mean? Well, it basically means marginal cost is the supply curve, right? Because you can see that by definition, supply curve essentially tells us if the price is P1, what should be the quantity? If price is P2, what should be the quantity? And you can see that here, marginal cost is giving us exactly the answer we want, right? It tells you that, look, if price is P1, the firm will want to produce Q1. If price is P2, then the firm will want to produce Q2. So, marginal cost curve is the firm's supply curve. Now, if you look at this lecture note, it says that with some caveats. So, roughly speaking, marginal cost curve is a competitive firm's supply curve. However, this will only be correct under some conditions. The reason is because sometimes firm will shut down, right? So in this case, if the firm shuts down, then its quantity is always zero, right? And we will discuss two kinds of shutdowns. The first is the actual shutdown or temporary shutdown. It basically means that the firm will shut down temporarily, only for a specific period of time. And importantly, this is a short-run decision. That is, the firm will shut down in the short run, and in the future, if the market becomes better, the firm could reopen. And then the second case is exit. In this case, the firm decides to exit the market. This is a long-run decision. It means that the firm will leave the market forever. So why do we want to talk about these two different kinds of time horizons, short run versus long run? The reason is because in a short run, the firm cannot avoid fixed cost. Remember, fixed cost is in our previous example, fixed cost is the cost of building your factory. So you can see that even if you decide to shut down in the short run, you cannot sell your factory. The fixed cost is still there. But in the long run, this will be different. In the long run, there won't be any fixed costs. Any costs will become variable, right? If you had built a factory, in the short run, it's a fixed cost. But in the long run, it will become a variable cost because you can sell this factory if you decide to exit the market. Okay, so let's look at this very simple example. So let's consider the decision of a farmer, right? In this case, what is this farmer's fixed cost? Well, it's the land cost, right? So maybe the farmer has rent the land from someone, and then the farmer has to pay this rental fees per year. So no matter whether the farmer decides to produce any so no matter whether this farmer wants to produce any crops one season, then the farmer always needs to pay this land rental fees, right? And in this case, you can see that in the short run, the firm cannot recover this fixed cost. because he has to pay this land rental fee. And then in this case, we call this fixed cost of land as sunk cost. It is a sunk cost because you have rented this land and you always need to pay the rental fee. So essentially, sunk cost is a cost that has already been committed and cannot be recovered. So in the case of sunk cost, you can think about the famous saying, don't cry over spilled milk, right? So the milk has been spilled. So there's no use to cry over it. You have rented this land as a farmer. So even if you don't grow anything, you would still have to pay that rental fee, right? So crying over your rental fee will not help you at all. So basically, you can see that sunk cost plays no role in short-run decisions. The reason is because the cost is sunk. You cannot recover it. So if you're making short-term decisions, the sunk cost will not affect your production or consumption decisions, right? So basically, the gist here is sunk cost can be ignored when you're making short-term decisions. Now, what about in the long term? Well, in the long term, it will be different, right? So if the farmer decides to leave farming altogether, that is, the farmer wants to exit the market, the farmer can sell the land if he owns the land. If the farmer does not own this land, then the farmer can terminate the rental contract, right? So you can see that in this case, after selling the land or terminating the rental contract, there will be no further cost. So you can see that in the long run case, the cost of land is not sunk, right? So you can see that whether a cost is fixed or variable, or whether a cost is sunk or not sunk, really depends on this time horizon, right? If it's a short horizon, then a fixed cost would be a sunk cost. If it's a long run horizon, then a fixed cost would not be a sunk cost. Okay, let's look at this further example. This is a old example I used in previous years. So let's say you spent $1 of gas to drive to the university, and you think your time spent in my class costs you $2, right? So you can see that your total cost would be $3. You expected to get $5 benefit from my class. So you can see that 5 is larger than 3. So you get $2 profit. So you would be happy to go to my lecture. Now, arriving at after watching after watching my lecture note, after 5 minutes, you think my class is only worth 2.5, right? So you can see that 2.5 is smaller than your total cost. Now, should you expect the class or not? Well, you should not, because you should only compare 2.5 with your $2 variable cost. This $1 cost of coming to the university is a sunk cost, right? You cannot recover this $1. So you can see that in this case, as long as the revenue is larger than the variable cost, then you should not escape the class, right? Okay, this is just a real life example, but you can see that you should apply the same logic to a firm's decision on whether to shut down or not. Remember that shutdown is a short run decision. So when a firm decides whether to shut down, it should compare its revenue with its variable cost. Again, fixed cost should not play a role in firm's decision to shut down or not. So essentially, you can see that the result is if total revenue is smaller than variable cost, then the firm should shut down, right? So this is our result on when firm should shut down. And now you can see that this result can be further manipulated mathematically. So if total revenue is smaller than variable cost, then we can divide the two sides of this inequality by quantity, right? And what is total revenue divided by Q? It's just average revenue, right? Now, what is variable cost divided by Q? Well, it's just average variable cost. And we know that for a competitive firm, average revenue equals price. So you can see that the shutting down condition can be also written as the firm will shut down if price is smaller than average variable cost, right? So this can be shown on this cost curve. So you can see that this is our marginal cost curve. This is our average variable cost curve. Initially, we said marginal cost curve is the firm's supply curve with some caveat. So now we're talking about what is this caveat exactly about. Well, you can see that, let's say if the price is here, right? This is the shutting down price. What you can see here is from this point, you can see the price is equal to, so at this point, price is equal to average cost curve, right? And you can see that for these prices, they are all smaller than average cost curve. And obviously for all these prices, they are all larger than average variable cost. So what you can see here is firm will shut down here, right? It basically means that if price is below this shutdown price, then firm will only produce zero quantity. So the supply curve is given by this red vertical line here. And then if price rises above this ABC curve, then the firm will produce a positive amount. So you can see that if price is larger than this average variable cost, then supply curve will be the same as the marginal cost curve, right? So essentially you can see that the lowest point on this average variable cost, right? So this is the lowest point on this ABC curve. So this point gives us shutdown price, right? And essentially the complete supply curve is given by this vertical line here, and then this marginal cost curve. Right? So you can see that this portion of the marginal cost curve is not supply curve. The reason is because for this portion, the price is too low. The firm has already shut down, right? So that's the caveat we kept talking about. Okay, now let's talk about the firm's decision to exit. So if you think about the firm's decision to exit, then you can see that this is a long-term decision. And if a firm decides to exit, it loses all revenue, but it could save both fixed cost and variable cost. It can save fixed cost because in the long run, fixed cost can be recovered. So you can see that a firm will only exit the market if revenue is smaller than total cost. That is the sum of variable cost and fixed cost, right? So this is our result here. Again, we could do some mathematical manipulation. So if total revenue is smaller than variable cost, then total revenue divided by quantity is smaller than variable cost divided by quantity. And now, what is total revenue divided by quantity? Well, again, it's average revenue. And we know that in competitive market, average revenue equals price. So now we have price smaller than... Okay, you know what? There's again a typo here. I have to update this lecture note. So you can see that we should not have variable cost here. We should have total cost here. Right? So let me restart. So we have this condition: total revenue smaller than total cost, and then we divide it by quantity. So this gives us average revenue smaller than average total cost. And then we know that for a competitive firm, average revenue equals price. So the condition for a firm to exit the market is price smaller than average total cost. So you can see that the minimum point on the average total cost curve gives us the firm's exit price, right? So you can see that again, use the same methodology we talked about this firm's shutting down decision. We can talk about the firm's long run supply curve. So we could see that this is the exit price. And for prices smaller than this exit price, firm will exit. So this portion of marginal cost curve is not supply curve. And then this portion, that is for the price which is larger than the exit price, this portion would be the supply curve, right? So the complete supply curve is given by this vertical section and this upper section of this marginal cost curve. Okay, now let's talk about calculating firm's profit. Obviously, we have learned about this, right? We know that profit equals total revenue minus total cost. But you can see that we could manipulate this formula. Total revenue equals P times Q. Total cost times average total cost times Q. And then we can combine P and ATC, right? So profit would be the difference between price and average total cost times quantity. The benefit of using this formula is we could easily measure firm's profit using pictures. So let's see this graph on the left. What you can see here is the firm's profit is given by the difference between price and ATC, right? So this is the difference times quantity. This is the quantity, which means the profit is given by this shaded area. Right? And then on the right hand side, in this graph, you can see that again, the profit is given by the difference between price and ATC times quantity. Right? So again, this shaded area gives us the firm's profit. But what you can see here is average total cost is larger than price. So essentially the firm's profit is smaller than zero, right? So clearly in this time, the firm is having a loss instead of a profit. Okay, now let's look at this quick quiz question. First, how does the price faced by a profit maximizing competitive firm compare to its marginal cost? Well, we learned price equals marginal cost. Right? When does a profit maximizing competitive firm decide to shut down? Well, we learned if price is smaller than average variable cost, then the firm should shut down. Or you could say if total revenue is smaller than variable cost. Right? These two conditions are the same. When does a profit maximizing competitive firm decide to exit a market? Well, we know that price smaller than ATC, that's the exiting condition. Or you could use total revenue smaller than total cost. Again, these two conditions are the same. Okay, now let's look at this very simple question. Determine this firm's total profit and identify the area on the graph that represents the firm's profit. So this should be easy, right? Because profit is P minus ATC times Q. What is P here? It's 10. And average total cost at quantity of 50 is 6. And quantity is 50. So this is 200. And then we have identified the area. Well, so we have the difference between the price and average total cost as this section, right? And then quantity is just 50. So the area which identifies profit is like this. Okay, second, identify the firms. Oh, so this is a different firm, right? Yeah, this is a different firm. So determine the firm's total loss. Identify the area. Well, the total loss would be price minus average total cost times quantity, which is minus 60. And the area would be given by, first, the difference between these two numbers and the quantity. So this is the area which shows us the loss of this firm. Okay, now let's talk about the supply curve in a competitive market. When we're talking about, so basically in the first half of this chapter, we talked about a single firm's supply curve, right? The result is, roughly speaking, marginal cost curve gives us a firm's supply curve. However, you have to consider the firm's decision to shut down or exit the market. Now, we want to think about the market supply curve. Clearly, market supply curve is different from a single firm's supply curve because a market has multiple firms, right? And we will consider two cases. The first case is we will consider a market with a fixed number of firms. So when we consider a fixed number of firms, we're essentially thinking about the competitive market in the short term, because in the short term, the number of firms should be fixed. But you can imagine that in the long term, the number of firms in the market can change, right? Because old firms can exit and new firms can enter, right? That's why we want to discuss two different cases. Okay, now let's think about a market with 1,000 identical firms in the short term. So first, you should understand how do you go from one single firm's supply to the market supply. So you can see that if you are having this one single firm, right? And you could see that at price of 2, it supplies 200 quantities. Now, if we assume all firms are the same, if we have 1,000 firms, we have 1,000 identical firms. In this case, you can see that the total number of, or the total quantity supplied in the market would be 200 times 1,000, which is 200,000, right? So it's a quite obvious calculation here. Now, what about in the long run? Well, in the long run, new firms can enter, old firms can exit. And then we will have a very important result. That is, in the long run, competitive firms will earn zero economic profit. Now, why do we get this result? Well, the reason is you can assume, right? Let's say if profit is larger than 0. Now, this basically means that new firms will want to enter into this market, right? Because they can earn positive economic profit. But if new firms enter this market, then it will increase the market supply curve. And in this case, the price will be lower. So the profit will be driven down to 0, right? Now let's assume if profit is smaller than 0. Now you can see that if this happens, some firms will want to exit the market. So after some firms exiting the market, then there will be fewer firms in the market, which means the supply curve will shift to the left and the price will be higher. So in this case, profit will be driven up to 0. So you can see that in the end, the market will always have this 0 economic profit. Okay. Now, let's talk about another result. That is, in the long run, because a firm can enter and exit the market, then all firms will earn 0 profit, and all firms will operate at their efficient scale. Remember what is the definition of efficient scale, right? So we learned if we have this average total cost curve, then the quantity which minimizes the average total cost is the efficient scale, right? So how do we get this result? Well, it's a combination of several results we have learned. So we have learned profit maximization, right? So if a firm is maximizing its profit, then price equals marginal cost. And we also learned in the long run, competitive firms will earn 0 profit. And we know that profit equals P minus ATC times quantity. So if a firm is earning 0 profit, then this implies price equals ATC, right? So if we combine these two results, we can see that marginal cost equals ATC, right? But we have learned in the previous chapter that marginal cost curve always crosses the average total cost curve at its lowest point, right? So you can see that the only way that average cost can be the same as marginal cost is the firm is having a quantity which minimizes its average total cost, right? So you could see this from this picture. That is, you have this average total cost curve here, right? So this is the ATC curve, and this is the marginal cost curve, right? So what you can see here is we understand that marginal cost equals average total cost, right? We just made the argument here. So from this picture, you can see that the only way you can have marginal cost equals average total cost is you're at this point, right? Let me use it different color. You're at this point. But you can see that this point is exactly the lowest point of the average total cost curve. And by the definition of efficient scale, you can see that the firm must produce at this Q here. That is, in the long run, the firm must produce at the efficient scale. And also you can see that in the long run, you have this neat result. So P equals marginal cost curve equals average total cost, right? Okay, that's for today's class.